Friends, this question from 16th March 2025 Quiz 2 Deep Learning. Consider the inception module use types of architectures. So one of this is GoogleNet architecture for the input size of 28 cross 256. So this is an input size of 256. 256 is the depth DPDH depth D, small d or capital D you can use. Height 28 is the height and 28 is the width. Height and width of the input 28 cross 256. So there are 4 blocks numbered 1, 2, 3, 4. So there are 4 blocks. So that is block 1, 2, 3 and this is the 4 blocks numbered 1, 2, 3, 4. Blocks 1, 2, 3 are made up of 2 layers each. So that is block 1 is made up of with 2 layers. This is layer 1, layer 2 also, that is 2.1, 2.2 second layer. This is 1.2 represents the first layer of block 1. So this one is block 1. This is the layer number, layer 2. Block 1, layer 2. This is block 2, layer 2. This is block 3, layer 1. Block 3, layer 2. Filter concatenation is the final stage. Okay. So denoted as x.1 and x.2 in the sequence. Okay. Next, in the same question, the input size is, that is 28 cross 2. So this is width cross height cross D is the depth. F is the spatial size, that is spatial size means filter size. General filters are symmetrical filters, that is square sizes. General filters are symmetrical square sizes, that is generally 3 cross 3. That two odd numbers. Most of the filters are odd numbers, 5 cross 5, 7 cross 7. Square filters. Rectangular filters are also available, but in this course mostly they use this type of filters. K represents the capital K number of filters. Okay, and stride is S equals to 1 and P is the padding size, 0 padding size. There are different types of paddings. In that one type is 0 padding. Suppose the width, height and depth represents the number of channels. So here they mention depth represents the number of channels. Here depth D equal to 256. So that is they use capital D. So we also represent with capital D. That is better. 256. Then the feature map volume. Generally volume tensors are 3-dimensional. So they has volume V. Volume equal to width times height times depth, right? So in this the feature map volume of the tensor 3D array WHD multiplication of WHD. The sub question will go through the blocks in the sequence, block 4, 1, 2 and 3. Okay, you can so in the question 1, what is the feature map volume after applying 4, that is block 4. This one is block 4, which is the convolution layer. So generally they given an input of 3-dimensional of 28. This is the 28 and depth D equals to 256. That is the input image size of 28 cross 256 is passing through a layer which is convolutional layer, and the output is, so we don't know output. Convolutional layer with f equals to 1, that is spatial size, that is filter size. F equals to filter size. F equals to filter size of 1. 1 means 1 cross 1. Filter size 1 cross 1, and k is the number of filters, that is 128, and stride s equals to 1 and padding equals to 0 on the input. What is the feature map volume? They are asking feature map volume after applying the block 4. So this is the block 4, right? This is the block 4. Here the convolutions 128. So this is 128 cross 1 cross 1. The output size after convolution of the input. This is the input size. Output size equals to input size minus filter plus 2 times padding divided by stride plus 1. That equals to input size is 28 cross 28, I equals to 28, minus filter size is 1 cross 1, right? So that is 1 plus 2 times padding is 0 by stride equals to 1 plus 1, that is 28. So this is the output size of 28 cross 28, the output size. And they are asking the feature map volume. So that is feature map volume after convolution. After convolution. So that is feature map volume. How do you find? W times, that is volume V equals to W times H times depth D. So width and height are 28 cross 28, and depth is very important, you can remember. For convolution layers, depth is K, the number of filters, this value, not this depth. This is the input depth. This is between this layer only. Input depth D is in this layer. After the convolution, the output is this size, output size. That is depth D equals to 128 filters. So you can remember, after convolution layer, number of filters is the depth of the image. That is, answer is 100352. This is the feature map volume of the output after convolution. Okay, this is the answer correct. Question number 2. What is the total number of parameters in block 4, which is the convolution layer with filter size 1k, number of kernels is 28, stride equals 1, padding equal to 0. So the same question they are asking number of parameters. They are asking in the convolution layer has parameters. The number of parameters in the convolution layer. Total number of parameters in convolution layer. How to find? That is the weights per parameter is equals to, so dp depth times filter size. So here the depth is, which depth you have to use? This is in the convolution layer, right? Up to this the depth is D input, that is 256. This is the value, that is 256 times the filter size is 1 cross 1 in the convolution layer. They mentioned in the convolution layer 1 cross 1. In block 4 also. In block 4 they mentioned convolution layer, this is 1 cross 1, that is filter size. So that is 1 cross 1. So that is 256 weights per parameter. Weights, total weights plus bias also. Bias also we can add. So weights equal to 256. If they mention in the question bias, ignore the biases. That is b equals to 0. That is b equals to 0. That is total parameters are 256. Total parameters. Total parameters. Parameters per filter, per one filter. So how many filters we have? We have k equal to number of filters 128 filters. So that is for 128 filters how many parameters? 128 times 8 times 256, 32,768 parameters. So this is the answer for this question. This is the answer for this question. You can remember up to complete convolution layer, the depth is input depth. This value input depth. After output, the depth is 128. K is the number of filters. You can remember both these 2 points. That is enough for this question to solve. Very easy. In the answer for this question is, what is the feature map dimensions? They are asking feature map dimensions. W width, H height and D depth after applying the 2 convolution layers. So 2.1 and 2.2, that is 2 represents the block 2. Block 2, 1 is layer 1, 2 is layer 2. 2.2 means second block, second layer, second block, first layer. Okay, in succession on the input. So for the 2.1, so this is the convolution layer 1 parameters. This is the convolution layer 2 parameters. The filter size is 1 and k number of kernels is 32. Stride equals 1, padding is 0. For the block 2 layer 2, filter size is 5 means 5 cross 5. K equals to 96. Number of filter size is, stride is 1 and padding is 2. So in this figure, so they mentioned block 2, right? So this is the, so this one is the input dimension of 256. That is same input size 256, 28 cross 28 dimension. If we apply the layer 2, this one layer 2, that is 32 filters, that is number of kernels, 1 cross 1 convolutions, dimensionality reduction. And for the layer 2, 2.2, apply this 96 filter size, 5 cross 5 filter size convolutions and reduced input. Because of this layer 1, the input is reduced, decreasing on the reduced input with padding equals to 2. So if we apply this and pass it through the filter concatenation. Okay. So in this question, so the input size is same 28 cross 256 is the depth. So because it is input of size means, so depth is D in input. So up to this convolution layer 1, the D input is the depth. Okay. So this is the convolution layer 1 parameters given in the, mentioned in the question. Filter size 1, kernel equal to number of kernels 32, stride 1, padding 0. And in this question they are asking, find the feature map dimensions of the after applying the 2 convolution layers. After applying the 2 convolution layers. So that is they are asking this and this. First we have to solve this one, the output 1 in the convolution layer after first convolution. How to find the output size? So that is the output size is equals to, what is the output size formula? Input size minus filter size plus 2 times padding divided by stride plus 1, right? So for this input size is 28 minus filter size is 1 plus 2 times padding is 0 by stride equals to 1, so plus 1. So this output parameters is 28. So that is generally width and height both are same for this question, that is w equal to h equals to 28 and d1, that is after first convolution layer the output d1 is the depth of the first convolution layer. After becomes d1 becomes k kernel size, that is 32. So this output image dimensions of the 28 cross 28 cross 32. This is the depth d1 32. That is the number of kernels. But they are asking this value, right? Layer the depth is d1. Okay. So how to find this output size? So for this the output size is equals to same formula, input size minus filter plus 2 times padding divided by stride plus 1. So that is the output size equals to input size here is 28 minus filter size is here 5 plus 2 times padding is 2, that is 2 by stride equals to 1 plus 1, that is 28 minus 5 is 23 plus 4 plus 1, same 28. So 28, here the volume 2, that is feature map volume 2 after the second convolution layer is 28. So w equals to width equal to height equals to same and depth d equals to the number of filters, right? Depth d1 d2 here is 96, that is 96 and 96. The feature map volume is 28 cross 28 cross 96. After convolution layer 2 the final output is this one. After convolution layer 1 volume 1 is 28 cross 28 cross 32. So 28 cross 28 cross 96. Okay, convolution layers. So that is here. So this volume is 28 cross 28 cross 96. And what is the total number of parameters in the two convolution layers? Total number means convolution layer 1, total number of parameters in the two convolution layers. Convolution layer 1 plus convolution layer 2 which are applied in succession on the input, ignore the biases. Convolution layer 1 so that is first we find weights per parameters. So depth times filter size, right? Filter size fs. Convolution layer depth is d input depth up to this layer output. Okay, this is the depth d input depth, same value, that is filter size is 1 cross 1. Please remember filter size 1 cross 1, not 1. So that is 256 times 1 cross 1, that is total 256 weights. These are weights. So in the question mentioned biases are 0. So bias is 0. So total parameters are weights plus bias is equals to 0, that is 256. You can multiply that is 256 parameters per filter, that is for one filter. So for how many filters are there? 32 filters. So 32 times 256. This is the number of parameters in convolution layer 1. So here the value is 8192, that is weights equals to depth. Here in depth is up to this layer, the depth is previous depth, right? This one, this value up to this layer, d1 times filter size. So d1 is depth is 32 times filter size is 5. Remember 5 cross 5, not only 5. Okay, these are weights. Biases is 0. So total parameters are 100. So that is 800 parameters per filter. So that is for 800 times. For here the number of filters are 96. So for 96 filters you multiply 76800. So that is number of parameters in convolution layer 2 or 76. Question they are asking total parameters after convolution layer 1 plus convolution layer 2, that is 8192 plus 76800 is 84992. These are the total number of parameters in block 2. So answer for this question is 84992, right? So this is correct answer. Which of the following options represent the feature map dimensions of WH width, height and depth after applying the 3.1 and the given the very important max pooling layer with filter size is 3. So here the filter size is 3 and stride equal to 1, p equal to 1 on the input. Here the input dimension is 256, depth and height and width are 28 cross 28 given in the question. So this is the input, this color. After passing through the max pooling layer of 3 cross 3, and this is the third block. Okay, for this they are asking find the feature map dimensions, that is max pooling layer. So how to find the output dimension size? That is the output size is equals to input size minus filter size plus 2 times padding divided by stride plus 1. 8 minus filter size is 3 plus 2 times padding is 1, stride equal to 1 plus 1 name. So the feature map volume that for this, that is W, H and D are 28 cross 28, that is height and width are same square shapes matrices, and the depth is up to this layer, the depth is same, that is input layer 256, depth D is D in. This is W equals to both H, all our values are same. So for this question the answer is this one, correct answer. And the continuation of the above question, and what is the total number of parameters in 3.1, that is third block. 3 represents the block 3 and 1 represents the layer 1. The max pooling layer with filter size 3, stride 1, padding 1. What is very important, the given is a max pooling layer. So that is the max pooling layer does not have any parameters, because the max pool layer does not learn any biases or parameter. It does not learn the weights or parameters. Only it can select the maximum value from the given input. It does not learn any weights and parameters. You can remember important for the max pooling layer there are no parameters, that is parameters are 0. This is the last question, friends. And which of the following options represent the feature map dimensions WHD after concatenating all the feature maps that come out of the 4 blocks? Already calculated each block in the previous question. For the first block we already calculated, that is block 4. Remember, this is block 3. This is the block 4. First we are calculated, first question. So this one, what is the feature map volume after applying the block 4? So we already calculated So this one, feature map volume, this one, that is 28 cross 28 cross 128. How? So for this 28 cross 28 cross 128 1. So this one, block 1.1 and 1.2, we already calculated in the previous question. 1.1 and 1.2. This one, blocks 1.1 and 1.2, feature map volume. What is the feature map volume? This is the question. So for this is the answer, 28 cross 28 cross 192. So this is the answer. So this block 1, 28 cross 28 cross 192. Block 2, that is 2.1 and 2.2 both for this question. So this one, 2.1 2.2, this one, because this is the parameter calculations, this is the feature map calculations. So 2.1 and 2.2 for this question. So this is the answer, 28 cross 28 cross 96. So this is 28 cross 28 cross 96. We already calculated for each block in the previous questions. So remember, for all these feature map volumes, that is feature map volumes, so the dimension is same, right? 28 cross 28 cross is same. That is, the spatial dimension is common. But in the final layer, so we have calculated up to this one only, block 3.1 only, right? 28. So here 28 cross 28 cross 256, block 3.1 only. Please remember, if you forgot this one, we will lose marks. So there is another block, right? This is also there, 64 cross 1 1 cross 1, that is 64 is the kernel size. So see, 64 we calculated up to 3.1 only. K and filter size is 1 cross 1. Okay, for this stride equal to 1 and padding equals to 0. For general values, these are common. For general, without mention, here they don't mention any values. For this, padding is 0, stride equals to 1. That is, so this is the input size is 28 cross 28 cross 256 is passing through a max pooling layer with size of 3 cross 3. We already calculated here. Filter size 3 cross 3, stride 1, padding 1. So they mentioned right, stride 1, padding 1 mention. For this we get the output 28 cross 28 cross 256. After this we use, that is block 3.2. Here in this question we already calculated only 3.1 only, no 3.2 block. So we want to calculate this also, don't forget. That is the convolution layer, and number of kernels 64, filter size is 1 cross 1. So they don't mention stride and padding. So in general we consider padding 0 and stride 1. For this, what is the feature map output? So for this, the output size is input size minus filter size plus 2 times padding divided by stride plus 1. So that is, input size is 28 minus filter size is 1 plus padding 0 by stride 1 plus 1. So that is 28, same. same value, that is 28 cross 28 cross up to here. The depth is same as here input depth, but here the number of filters are given. This is the depth, right? This is the depth D2 in the convolution layer, right? So depth D2 is 64. Up to here the depth is input depth Dn. After this the number of kernels are mentioned. So the feature map volume is 28 cross 64. This is the output, final output from block 3. Okay, so for this block 3 the answer is 28 cross 28 cross 64. So that is spatial width is common 28 and height is also common, same 28. So the final depth, so dpds, the final depth value is, you add all the depths, that is 192 plus 96 plus 64 plus 128, total 480. The final output feature map volume is 28 cross 28 cross 480. We are adding all the depths. Final concatenated, right? Concatenation, final concatenation means addition, that is adding, that is 480. So answer for this question is 480. So answer C is correct. Friends, thank you for watching. If you like my videos, please like and subscribe my channel.